Hello students, today's agenda is to check homework. We'll be learning about permutations and combinations, and you will be able to do 5.58. Today students will be able to use the formula for the number of permutations. A permutation is an arrangement where the order of the objects is important. You can use n factorial, where n is the number of objects. And so let's say that we put the letters of the word may, M, A, and Y in a bag and then get each letter out without replacing it. So it's similar to what we found for the sample space. Since this is a small word, not a small word, I'm going to use each letter and do the sample space so that you can see. And also to review, we are going to do a little bit of conditional probability here. The word may, you're going to be choosing letters in order. So for the first choice, you have three possibilities. So you have M, or you might choose A or Y. We don't know which one we choose, right? Because it's a random and we're getting it out of the bag. Once we go to the second choice, let's pretend that we chose M first. So now we only have two choices. So it's either A or Y for my second choice. I don't have any other choices. The M is already out. We did not replace it, so that's it. So let's say that I chose M for the first choice, A for the second one. I only have one choice for the third time I draw a letter. So the only one that is left in the bag is the letter Y. But let's say that no, what I did was I chose M for the first one, Y for the second one. That means that the only choice I have left in the bag is A. It's either this path or another. Let's say that this did not occur. What I had is an A when I chose it. And so what is left in the bag? For me to choose, if I chose A, that means that it's either M or Y. And if what I chose after the second one wasn't first A, then M, then the only one choice I have now is Y in here. But if it wasn't that, let's say that I chose A for the first choice, for the second one was a Y, then that means that there is only what left? Oh, it's M. But what if none of this occurred? If for the first choice I get Y, in the bag I have either M or A. Only one letter, which is A. The only thing that is left for me to choose from is M. So when I first put the letters in the bag, I had three letters to choose from. I put my hand in, there are three cards. Okay, so there are three cards. For the second choice, I took one out, I don't replace it. I have only two letters. For the last choice, as you notice, well, I already chose M, I already chose A. There's only one choice. So 3 times 2 times 1 was my total outcome. Okay, so 3 times 2 is 6. 6 times 1 is 6. And this is what they call 3 factorial. Okay, this symbol here is called factorial. If we were to do the sample space, then it's these combinations. I may get an M, A, Y in that order, or I may get M, Y, A. M, Y, A. Or maybe A, M, Y. A, M, Y. Or A, Y, M. A, Y, M. For the next one is Y, M, A and Y, A, M. So in the sample space, we see that there are 6 possible outcomes or arrangements, and that's what these are showing. Okay, this right here. Now, just to connect it to the previous lessons, and it's not the previous one, it's 5.3 actually. What is the probability that it starts with M, knowing, look at this, knowing that it ends with Y? When it says knowing, this is conditional probability. It means that you're only going to choose from the ones that end with Y. This is my condition. So I look at all of them and I notice that only these two end with Y. So that means that that's the total number of that goes in the denominator. And the one that goes in here is the probability that both starts with M and ends with Y. Which one of the two starts with M and ends in Y? Well, this one doesn't start with M and ends in Y, but this one does, so it's only one of them. Only one starts with M and ends in Y. So on the top, it's always the probability of the first event and the second event, okay? It's only one of them. This is just review. 1 divided by 2 is 0.5. We move it 2 spaces, so that's 50%. And this works only because the letters don't repeat, okay? So it says you put the letters of the word June in a bag and get out a letter without replacing it. Again, for the first choice, you have either J, U, N, or E. So you have 4 choices. For the second choice, you only have 3 choices, which is all the letters except the one that you got out first. So for June, for J, you only have U and E. And then for this one, you have J, not U, and E, because you already took that one out. For this one, you have J, U, not N, but E, yes. And for this one, you have all the three first letters. J, U, N, and not E, because you already took it out on the first draw. For the next one, you already took the first 2 letters, so we don't know which ones you get. But now you only have 2 choices left. For this one, you already took J and U, so you only have N, E in the bag. For this one, you took out J and N, but you still have U and E. And for J, E, that means that you already took out J, E, you only have N, U. So notice how for the first letter you had 4 choices, all 4 of them. For the second one, you only have 3. For the next one, you only have 2 for each path. And then for this one, at the end, you will only have, for this one is E, and for this one, you took J, U, and E, so you only have N in the bag. In here, you took J and U. That means that you only have E in the bag. For this one, you took J and E, so you only have U in the bag. Notice how in here, for the last one, you just exchange them because you take one and the other, okay? For this one, is going to be U. For this one, is going to be N. So you could do all of this for each one of them, because this is done for J, but not for the other ones. But you can do that, or you can just say for the word June, all you have to say is like, oh, 1, 2, 3, 4 of them means that you will have 4 factorial in the sample space. By finding that, you will get the total number of possible outcomes. What does that mean? It means it starts with that number and then multiplying by the descending numbers before that. So 4 times 3, which is this 3, times 2, which is this 2, or this 2, or this 2, times 1, which is that one choice that you have at the end or in the bag. And 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. So there are 24 possible outcomes. Now, let me say that sometimes we're able to arrange all the letters. Sometimes they ask you to arrange only the first two letters. So let me show you both. So for example, the word April, it doesn't have any repeating letters. And if it says arrange all the letters, well, we just count 1, 2, 3, 4, 5. The answer will be, so arrange all letters. So it will be 5 factorial, which means 5 times 4 times 3 times 2 times 1. And some of the calculators have that factorial. Some of them show it right in there, others are hidden. So you might have to explore your calculator. I'll show you in this one. Well, let me do it first without the calculator and show you what the answer is. 5 times 4, that's 20. 20 times 3, 60. 60 times 2, 120. 120 times 1 is 120. In the calculator, it's going to be 5, second key, and then you will notice that it says x factorial in here. You press that, and that will give you the answer. Oops. Again, 5, second function, and then there is something in there. Let me see if I can show you. It says x factorial. Not all the calculators have it right in there. Okay, so it's 5, second function, and then the x factorial is back there. Now, if it says arrange all letters, what if it says to arrange only the first two letters? So April, but arranging only 2 of the letters. What you're going to do is 5 factorial divided by that number minus the number that they told you to arrange. If they say 4, arrange 4 of the letters, arrange 2 of the letters, arrange 3 of the, that's the number that you're going to subtract from the total number of items in here, and factorial in here. What does that mean? It just means that you're going to put 5. Well, first subtract this part because otherwise you might go over in here. 5 minus 3 is 2, and you're going to put factorial in there. Notice how I wrote, it's supposed to be that number. I wrote the answer already. Okay, so subtract 5 minus 2 is 3, and put factorial in here. Okay, so again, what you do is count the number of items and put that in here. So in here is 5 factorial, and then put 5 minus the number and put factorial outside of the parentheses. Subtract that. 5 minus 2 is 3, and then in here now we can say 5 times 4 times 3 factorial. The reason is because we're trying to save space. We're trying to save time, because we could do 5 times 4 times 3 times 2 times 1, and here 3 times 2 times 1, and cancel the 1, cancel the 2, and cancel the 3. But instead, we can just stop where we subtract. That's where we're going to finish. I'll show you one more so that it makes sense. 3 factorial divided by 3 factorial. Remember that anything divided by itself is a 1. So 5 times 4 is 20, and 20 times 1 is 20. Again, when you're only arranging some of the letters, you have to do this extra step, which is subtracting and putting that in the denominator to divide. Okay, for the next one is going to be cake shop. How many letters are in cake shop? 1, 2, 3, 4, 5, 6, 7, 8. So that means that if we are going to arrange all the letters, arrange all the letters, then we're going to do a factorial. A factorial means a times 7 times 6 times 5 times 4 times 3 times 2 times 1. So show your work, but then use your calculator, because look at the number that we're going to get. Okay, so it's 8 second, and sometimes it says shift, okay? And then factorial, so it's 40,320 possible outcomes or lists of combinations. Now, what if we only arrange 3 of the letters? So it's going to be a factorial, and then in the bottom we put 8 minus that number. Watch me put a 5 because I always put the answer. So 8 minus 3 is 5 factorial. Do the denominator first so that you don't go over in here. And now we put 8 times 6 times 5 factorial. Okay, skipping some numbers. Okay, 8 times 7 times 6 times 5 factorial. Cancel 5 factorial divided by 5 factorial. Anything divided by itself is always 1. So now we just have 8 times 7 times 6. 8 times 7 times 6. 336 possible outcomes. So when you're going to arrange cake shop, but then you only arrange the first 3 letters, then it's going to be 336 possible outcomes. Now, just for the notation, when we have something like this where you arrange only a couple, the notation is like this. We're going to put P for the probability with 8 total items in the word, and then you only care about arranging 3 of them. So that's how it would look. And again, it all means is that this number goes on the top with the factorial. Then you subtract a minus 3 factorial, and you just put a minus 3 is 5, so 5 factorial. I'm just repeating, it's the same thing, but I just want to share that sometimes they give you a question as a notation, okay, in this format. So it's going to be 8 times 7 times 6 times 5 factorial. This cancels, and the rest you already know. 8 times 7 times 6 is 336. With this, we end our lesson. If you can please support us by giving us a thumbs up, subscribing around here. This is the list to the entire unit, and here you will find the next lesson. Now you're able to do 5.58 and have fun.